Somewhere in the constellation Virgo, 55 million light years from where you are sitting right now, there's a galaxy doing something that should not be possible. Every single galaxy you have ever heard of is running away from us. That is simply how the universe works. Space itself stretching in every direction, carrying galaxies further and further apart with every passing second. But this one galaxy refuses to play by that rule. It is racing toward the Milky Way at hundreds of kilometers every second. And the closer astronomers look at it, the stranger its story becomes. If you have ever wondered whether there are exceptions to the biggest rule in cosmology, stay with me, because this galaxy is one of the rarest objects Hubble has ever photographed, and what is happening to it right now might be a preview of something that will eventually happen to our own galaxy too. Let's start with the rule this galaxy is breaking, because you need to understand just how strange this really is. Since the early 20th century, astronomers have known that the universe is expanding. Edwin Hubble discovered this by noticing that almost every galaxy he observed showed something called redshift, meaning the light coming from these galaxies was stretched toward longer, redder wavelengths as it traveled toward us. This stretching happens because the fabric of space itself is expanding, carrying galaxies apart from one another, the same way raisins in a rising loaf of bread drift further apart as the dough itself swells, even though none of the raisins are moving through the dough on their own. The further away a galaxy is, the faster it appears to be receding, and the more dramatically its light gets shifted toward red. This single observation became the foundation of modern cosmology, the first solid evidence for the Big Bang itself. This relationship between distance and recession speed is known today as Hubble's law, and it turned out to be one of the most powerful tools astronomers have ever discovered. By simply measuring how far a galaxy's light has been stretched, scientists can calculate roughly how fast that galaxy is receding, and from that speed, estimate how far away it actually sits in space. It works almost like a cosmic speedometer built directly into the color of starlight itself. Because this relationship holds true across billions of galaxies scattered throughout the observable universe, astronomers use it constantly to map the large-scale structure of the cosmos, tracing out enormous filaments and clusters of galaxies stretching across hundreds of millions of light years. It is precisely because this rule works so reliably, so consistently, across such an enormous sample of galaxies, that any exception to it becomes immediately fascinating to scientists. A single galaxy behaving differently is not just a curiosity. It is a clue, a thread that, when pulled on carefully, can reveal something deeper about the physics playing out on a much smaller, more local scale. Given that rule, you would expect every galaxy in the observable universe to show this same redshift, this same stretching of light, the same signature of retreat, and the overwhelming majority of them do. But every so often, astronomers stumble across an exception, a galaxy so close to us and moving through space so fast on its own that its personal velocity actually overwhelms the expansion of the universe itself. Instead of redshift, its light shows blue shift, compressed toward shorter, bluer wavelengths, the unmistakable signature of an object hurtling toward us rather than away. The Andromeda Galaxy, our nearest large neighbor, is one famous example, destined to collide with the Milky Way billions of years from now. But there's another galaxy, less famous, considerably more extreme, and considerably stranger, called Messier 90. Messier 90, sometimes labeled NGC 4569, sits inside the Virgo cluster, an enormous gathering of well over 1,000 galaxies bound together by gravity, located roughly 55 to 60 million light years from Earth. The Virgo cluster as a whole is doing exactly what cosmology predicts, drifting away from us as the universe expands. But Messier 90 is not behaving like an obedient member of that cluster. Instead, its light reveals a heliocentric velocity of roughly 235 kilometers per second, directed toward us, one of the largest blue shifts ever measured for any galaxy in the night sky. Only one other Messier catalog galaxy, Messier 86, shows a comparable inward velocity, and even that one trails behind M90 in sheer speed. Out of thousands of galaxies astronomers have cataloged and measured, this puts Messier 90 in an extraordinarily small, strange club. Messier 90 was first discovered by the French astronomer Charles Messier back on March 18, 1781, during the same prolific observing run in which he cataloged several other prominent members of the Virgo cluster, including Messier 88 and Messier 91. At the time, of course, nobody had any concept of redshift, blue shift, or an expanding universe at all. Those ideas were still a century and a half away from being discovered. Messier was simply cataloging faint, fuzzy patches of light in the sky so that comet hunters of his era would not mistake them for actual comets. It is a strange twist of scientific history that one of the objects on that 18th century list of things to ignore would eventually become one of the most scientifically important blue-shifted galaxies known to modern astronomy. Spanning roughly 130,000 light-years across, Messier 90 is actually somewhat larger than our own Milky Way, and under sufficiently dark skies, it can even be spotted through a pair of good binoculars, appearing as a faint oval smudge of light long before any telescope reveals the true drama unfolding within it. Here is where the story gets genuinely wild. Astronomers do not believe Messier 90 is simply moving toward us in a straight line the way a car might drive toward you down a highway. Instead, they believe its blue shift is a side effect of something far more chaotic, its own orbit through the Virgo cluster itself. The cluster's combined gravitational mass is staggering, and galaxies caught within it do. Not orbit in gentle, predictable circles the way planets orbit a star. They get flung onto wild, looping, unpredictable paths, sometimes called peculiar velocities, that can send a single galaxy hurtling toward Earth for a stretch of cosmic time before eventually swinging back the other way. Roughly 300 million years ago, Messier 90's orbit carried it dangerously close to the crowded, gas-rich center of the Virgo cluster, and that encounter appears to have accelerated the galaxy to such an extreme speed that it is now on a trajectory to escape the cluster's gravity entirely, flinging itself out into the emptier reaches of intergalactic space. And by sheer cosmic coincidence, the direction that trajectory happens to point is straight at us. That plunge through the dense heart of the Virgo cluster did more than just accelerate Messier 90. It also nearly gutted it. As the galaxy tore through the thick intergalactic medium sitting at the cluster's core, the sheer force of that passage acted like a violent deluge, headwind stripping vast quantities of gas straight out of the galaxy's disk. Hubble space. Telescope images captured in stunning detail reveal a diffuse, ghostly halo of stripped material now surrounding Messier 90, gas that used to belong inside the galaxy and has now been torn away entirely. That gas was the galaxy's fuel supply, the raw material needed to keep forming new stars. Without it, astronomers expect Messier 90 to gradually fade, its once vibrant star forming spiral arms slowly dimming over the coming eons as its existing stars age and die without replacements being born to take their place. In other words, this galaxy is simultaneously being flung toward us and slowly killed by the very same violent encounter, a spiral galaxy racing toward its neighbors while quietly dying from the wound that gave it that speed in the first place. To really appreciate how dramatic this transformation is, it helps to picture what Messier 90 likely looked like before that fateful plunge through the cluster's core. A healthy spiral galaxy like this one is normally rich with cold hydrogen gas woven through its spiral arms, the essential raw ingredient collapsing under its own gravity to birth new stars continuously, generation after generation, for billions of years. Galaxies full of this kind of active star formation tend to glow with the telltale blue light of young, hot, short-lived stars clustered along their spiral arms, giving them a vibrant, structured appearance. But once a galaxy loses its gas supply, that active star formation grinds to a halt almost entirely. The existing population of stars keeps shining for a while, but without fresh gas to replace them, the brightest, bluest, most massive stars burn out first, leaving behind an increasingly reddish, increasingly quiet galaxy, still recognizably spiral in shape, but essentially frozen in time, coasting on borrowed light from stars that formed long before its brush with the cluster's core. Messier 90 currently sits somewhere in the middle of that transformation, still displaying visible spiral structure and pockets of star formation, but already showing clear signs of the gas-depleted, quieting future that likely awaits it. It is worth pausing here to correct a common misconception before it spreads any further, because you may have already seen headlines online claiming this kind of story involves the James Webb Space Telescope uncovering some brand new anomaly that breaks the laws of physics. That is not accurate, and it is important to be honest about where this science actually comes from. Messier 90's blue shift has been documented by astronomers for decades, and the most detailed, most widely circulated recent images of it come from the Hubble Space Telescope, not James Webb, captured using its wide field and planetary camera along data from the FANGS Hubble survey, a long-running project dedicated to mapping the structure of nearby star-forming galaxies in extraordinary detail. Nothing about Messier 90's motion violates any law of physics either. It is a completely natural, well-understood consequence of how gravity behaves inside a massive galaxy cluster. What makes it remarkable is not that it breaks the rules of cosmology, but that it is one of the rare, spectacular exceptions those rules allow for, a genuine needle in a haystack of thousands of otherwise perfectly obedient, red-shifted galaxies. So why does a phenomenon like this actually happen? Picture the Virgo cluster as an enormous swarm of over 1,000 galaxies, all bound together by their combined gravity, orbiting a common center of mass the way bees swirl around a hive, except on a scale spanning millions of light years. Individually, each galaxy inside that swarm can pick up enormous velocity as it swings through the Cluster's gravitational field, especially if its orbit carries it close to the crowded, mass-dense core where the pull is strongest. Because the cluster is not a smooth, orderly structure, but a chaotic gathering of galaxies constantly tugging on one another, these orbital paths become wildly unpredictable, sending individual galaxies shooting off in seemingly random directions at extreme speed. Some of those galaxies happen to be flung roughly toward the Milky Way. Others get flung roughly away from us, adding their own velocity on top of the cluster's overall recession, making their observed redshift even more extreme than it would otherwise be. Messier 90 simply happens to be one of the unlucky, or depending on how you look at it, one of the fortunate few caught mid-swing on the inbound leg of that chaotic orbital dance, its personal velocity toward us of roughly 235 kilometers per second, easily overpowering the gentler outward pull of cosmic expansion at this relatively close distance of 55 million light-years. This kind of velocity, sometimes called a peculiar velocity by astronomers to distinguish it from the smooth, predictable recession caused by cosmic expansion, turns out to be surprisingly common across galaxy clusters in general, even if Messier 90's specific case is unusually extreme. Every galaxy embedded inside a massive cluster is essentially caught in a permanent gravitational tug-of-war, pulled simultaneously by the combined mass of every other galaxy. Around it, by any large central elliptical galaxy that might anchor the cluster's core, and by vast, invisible reservoirs of dark matter that make up the overwhelming majority of any cluster's total mass. These competing pulls send individual galaxies swinging along looping, elongated, sometimes wildly eccentric orbital paths that can take hundreds of millions or even billions of years to complete a single full circuit. A galaxy near the calm outer edges of a cluster might drift along gently, barely perturbed. A galaxy that happens to plunge close to the dense, violent core, as Messier 90 did roughly 300 million years ago, can emerge from that encounter permanently transformed, both in terms of raw velocity and in terms of its physical structure and gas content. Astronomers studying clusters like Virgo essentially have to think less like they are tracking a tidy solar system, and more like they are trying to predict the paths of individual molecules bouncing around inside a turbulent, churning fluid, each one influenced by every other one simultaneously. None of this means Messier 90 is actually going to collide with the Milky Way. And this is an important point to make clear before anyone's imagination runs too far ahead. Astronomers studying its trajectory believe the galaxy's overall path is carrying it out of the Virgo cluster entirely, off into the emptier expanse of intergalactic space that lies beyond the cluster's gravitational grip, rather than on any collision course toward our own galactic neighborhood. Its current blue-shifted motion toward us is a real, measured, physical fact. But the vast distances involved, 55 million light-years is roughly 520 billion kilometers, mean that even a velocity of hundreds of kilometers per second results in almost imperceptibly slow progress on any timescale that could ever matter to human civilization. Even relative TO the Virgo cluster itself, Messier 90 appears to be moving at close to 1,500 kilometers per second, an almost unimaginable speed by everyday standards. And yet, against the sheer scale of intergalactic distances, that velocity still translates into a journey measured in hundreds of millions of years, rather than anything remotely resembling human history. This is less a story about impending collision and more a story about how astonishingly chaotic and dynamic galaxy clusters actually are beneath their serene, static-looking photographs. What makes Messier 90 such a valuable target for continued study is that it offers astronomers a rare natural laboratory for something called ram pressure stripping, the process by which a galaxy moving fast through a cluster's diffuse hot gas gets its own interstellar material physically stripped away by the pressure of that passage, much like wind ripping the tarp off a moving truck. This process is believed to be one of the primary reasons galaxy clusters are dominated by quiet, aging, gas-poor galaxies, rather than the vibrant, actively star-forming spirals more common in emptier regions of the universe. Ram pressure stripping does not happen instantly. It unfolds gradually as a galaxy repeatedly plunges through the densest regions of a cluster, each pass tearing away a little more of its gas reservoir until eventually what remains is a stripped, gas-starved husk of its former self, technically still classified as a spiral galaxy based on its visible structure, but functionally incapable of sustaining the kind of ongoing starbirth that once defined it. Because Messier 90 is caught mid-transformation, still recognizably spiral, still visibly beautiful, but clearly in the process of losing its star-forming fuel and drifting toward a much quieter future, it gives researchers a genuinely rare snapshot of a galaxy caught in the act of this slow, violent metamorphosis. Recent studies using data from the Planck Space Observatory have even detected a subtle temperature asymmetry in the microwave background radiation surrounding Messier 90's halo, likely tied to the rotation of the stripped gas envelope itself, adding yet another layer of ongoing scientific interest to this single unusual galaxy. There's also something quietly humbling in all of this, if you sit with it for a moment. For most of human history, the night sky looked like the very definition of permanence, fixed points of light that seemed utterly unchanging from one generation to the next. Modern astronomy has revealed the opposite, a universe in constant, violent, chaotic motion, galaxies torn apart by cluster gravity, flung across vast distances at hundreds of kilometers per second, some racing away from us, and some, like Messier 90, racing toward us, all of it playing out over timescales so vast that not a single human being who has ever lived could witness more than a single motionless frame of the whole unfolding drama. We happen to exist at precisely the right moment, with precisely the right instruments, to catch one of these rare exceptions in the act, a galaxy defying the overall expansion of the universe, not through any mystery beyond physics, but through the sheer chaotic power of gravity, acting exactly the way Einstein's equations say it should. It is also worth remembering that our own Milky Way is far from a passive bystander in this kind of cosmic drama. We already know that Andromeda, our nearest large galactic neighbor, is closing in on us through its own blue-shifted approach, destined to merge with the Milky Way several billion years from now in a slow gravitational dance that will completely reshape both galaxies over hundreds of millions of years. Our own galaxy, too, has almost certainly experienced its own share of violent encounters and gas-stripping episodes over its 13 billion-year history, absorbing smaller dwarf galaxies, tearing streams of stars away from satellite systems like the Sagittarius dwarf, leaving faint scars written into the structure of our galactic halo that astronomers are still piecing together today. Messier 90 simply offers us a rare, visible, actively unfolding example of a process that has almost certainly shaped our own cosmic neighborhood as well, just usually far too slowly and far too subtly for any single human lifetime to notice directly. If stories like this one, real discoveries about the strange, chaotic behavior hiding behind the calm surface of the night sky, are the kind of thing that keeps your curiosity burning, go ahead and hit that subscribe button, because this channel is built entirely around digging into exactly this kind of science every single week. And if this particular story genuinely surprised you, if you had no idea a galaxy could be racing toward us while simultaneously being torn apart by the very collision that gave it that speed, do not forget to like this video. It makes a real difference in helping stories like this one reach more curious viewers just like you. So the next time someone tells you that everything in the universe is moving away from us, you now know the real answer is more interesting than that. Somewhere out there, 55 million light years away, one lonely spiral galaxy is doing the opposite, hurtling toward the Milky Way at extraordinary speed. Its gas stripped away, its future dimming, caught forever between the eye pull of a cluster it is escaping, and the long, slow fade that violent escape has set in motion. It will not reach us in any time frame that matters to a single human life, but it stands as a permanent reminder that even the most fundamental rules of cosmology come with fascinating exceptions, if you know exactly where in the sky to look for them, and that the universe, for all its vastness, is still full of individual stories playing out on scales that dwarf anything we could ever hope to fully witness. Thanks for watching all the way to the end. Drop a comment and let me know which cosmic mystery you would like this channel to dig into next, and I will see you in the next video.